Okay, this is chapter 6, probability, and 6.1 is about simulations. There's 5 steps to do the simulations when you do application questions. The first one is to state the problem or phenomenon, and the second one is to state the assumption, and the third one is to assign digits to represent different outcomes, and then you simulate many repetitions, and then at last you summarize the info and draw conclusions. The examples of simulations including flipping a coin and rolling a dice, random number generator, and random digit table.
Section 6.2 includes different probability methods. Here are some important vocabulary, but two that we feel are most important are sample space and probability model. Sample space is a set of all possible outcomes, and probability model is a mathematical description of a random phenomenon consisting of two parts, a sample space S and a way of assigning probabilities to events. And these probabilities can be expressed as both tree diagrams and Venn diagrams. So in order to understand, you should know the concept of sampling with and without replacement. For example, using a deck of cards, it's a matter of if you put the card back in, which is replacement, and without replacement is if you take the card out. The multiplication principle is N1, which is the number of ways to complete task 1, and N2 is the number of ways to complete task 2. So N1 times N2 is the number of ways both tasks can be done. When understanding probability, it is good to know that the probability of a sample is 1, and the probability of any event occurring is between 0 and 1. The addition rule states that the probability of event A or B occurring is the probability of A occurring plus the probability of B occurring, and this is if and only if A and B are mutually exclusive. Mutually exclusive events, also known as disjoint events, they have no outcomes in common. The complement rule states that the probability of the complement of A is 1 minus the probability of A. For example, say the event was rolling a 6. The complement of rolling a 6 is the probability of rolling a 1, 2, 3, 4, or 5. Notation and probability uses these two symbols, union, which means or, and intersection, which means and. Independent events. This is knowing one outcome did or did not occur doesn't change the probability of the other outcome occurring. Also, disjoint events cannot be independent, or also mutually exclusive events can't be independent. The multiplication rule for independent events, the probability of A intersection B is the probability of A times the probability of B, if and only if A and B are independent. And finally, for 6.2, the probability of at least one happening is the 1 minus the probability of none happening.
6.3 talks about general probability rules, and first it introduces the idea of union. So union means the set of all possible outcomes that lead to at least one event occurring, and the equation of it, the probability of A union B means A occurs, B occurs, or both A and B occurs. So in this graph, it will be this part, or the middle. Some rules of probability will be the general addition rule for union of two events. So the equation will be probability of A or B happening equals probability of A plus probability of B minus probability of A and B happen. And the second one will be conditional probability rules. And here's the equation of it. Gives the probability of one event occurring under the condition of another event already happened. And the multiplication rule, it will be the probability that A and B occur together. And that